So the lipoprotein A will be having an additional apoprotein known as ApoA. Apo bracket we will put A in the small letters, right? So ApoA, and this ApoA is very dangerous because this ApoA will be always linked to the ApoB100. It's not having a direct access to the lipid molecules. The ApoA will be bound to or it will be in contact with ApoB100. So naturally it is a LDL molecule. Or ApoB100 we can see on the LDL molecule. So this ApoA that is containing LPA, lipoprotein A. So once the ApoB100 is attached to ApoA, then we no longer call it as an LDL molecule. It is known as lipoprotein A, LPA, and we call it as a nickname. We call it as little rascal because this lipoprotein A is having a close structural similarity with a protein known as plasminogen. So what's the function of plasminogen? Plasminogen will be enhancing the fibrinogen to convert it to get or undergoes, it makes the fibrinogen to undergo lysis to give the fibrin thread. That is, it prevents the clot formation, right? So that's a function of this plasminogen. So plasminogen enhances fibrinolysis. It enhances the fibrinolysis so that clot formation is prevented. But if lipoprotein A is found in the body in excess quantities, that is, if the value of lipoprotein A in a person's body is greater than 30 milligram percentage. Normally, a person will be having, majority population will be having only least quantity, minimum quantity, or it cannot be detected in the blood. If a person is healthy, the lipoprotein A cannot be detected. But in some persons, especially persons of younger age, we have, you might have read in the newspapers that the middle-aged people are getting died due to myocardial infarction, right? Cardiac arrest very 40s persons, okay. Usually cardiac arrest will be seen in old age, but if a person is having death due to myocardial infarction in his earlier age or a younger age, right, in a middle-aged person or a 35-40 years like a MI വന്നിട്ട് മരിക്കുകയാണെങ്കിൽ death ആവുകയാണെങ്കിൽ the reason may be due to the accumulation of lipoprotein A, because the lipoprotein A inhibits the plasminogen, or it is having a, it is very much closely similar to that of, structurally similar, it is very much closely structurally similar to that of plasminogen. So that instead of plasminogen, if lipoprotein A is present in the body, lipoprotein A goes and binds to the fibrinogen, so that the fibrinogen is not allowed to undergo lysis. As a result of which, what happens? It will be forming clot formation, thrombus formation. So these thrombus or the clots get deposited on the along the capillary walls, resulting in the hindrance of the blood flow. So oxygen supply will be reduced, resulting in myocardial infarction, sudden death. Right? That's why it is known as little rascal. So normally in a healthy person, the lipoprotein A is not found in detectable quantities. But if a person is having a value of lipoprotein A greater than 30 milligram percentage, they are more susceptible for undergoing cardiac arrest, and at a very young age. Okay. So and again the sad fact is that the lipoprotein A is more found in Indian population. Indian population are more susceptible for having a high value for the lipoprotein A in their body. So fibrinolysis is impaired, resulting in the thrombus formation and ultimately causing myocardial infarction. Right? So that is the lipoprotein A. And next is a high density lipoprotein. That is the lipoprotein whose function is exact reverse of that of the LDL molecule. LDL transports cholesterol esters from the liver to the peripheral tissues. While what does the HDL do? HDL transports the cholesterol esters from the peripheral tissues to the liver. And because of the same reason, it is known as good cholesterol, right? So it prevents the deposition of fat in the adipose tissue. Okay, so it is a circulating reservoir of ApoC and ApoE. During the course of this classes, you have seen that all the lipoprotein molecules are deriving the ApoE and ApoC from the HDL molecule. So it's actually a reservoir of ApoE and ApoC, and they delivers the cholesterol esters from the peripheral tissues to the liver. By the and this phenomenon is known as reverse cholesterol transport. The transportation of cholesterol from the peripheral tissues back to the liver by HDL molecule is known as reverse cholesterol transport, right? And so one of the functions is to act as a source for ApoC and ApoE molecules for other lipoproteins like VLDL, chylomicrons, LDL, etc. And another function is that it is responsible for transporting the cholesterol esters from the liver to the from the peripheral tissues to the liver. With the help of certain proteins are there, right? And protein will come to it. So the free cholesterol derived from the peripheral tissues are taken up by the HDL, and the ApoA1 that is present. The HDL contains ApoC, ApoE, and apart from that, the most important protein present in them is the ApoA1. And when we were discussing on the ApoA1, we have told that ApoA1 is anti-atherogenic in nature. That is, it prevents atherosclerosis, right? So how does it prevent atherosclerosis? It activates, ApoA1 activates the enzyme LCAT, that is lecithin cholesterol acyl transferase enzyme. That is, it transfers the LCAT, this enzyme transfers lecithin molecule to the cholesterol, so that cholesterol is having lecithin molecule. As a lecithin molecule always prevents the atherogenesis, right? So that is why HDL. So HDL is a potent activator of LCAT enzyme because of the presence of ApoA1. So HDL contains ApoA1. ApoA1 activates LCAT, lecithin cholesterol acyl or cholesterol acyl transferase. So this enzyme transfers lecithin molecule to the cholesterol, right? So that the cholesterol is made safe. Lecithin is protective in nature, right? Lecithin or phosphatidylcholine. So it is very much protective in nature. It is a lipotropic factor. What are lipotropic factors? We'll study. Okay. So lipotropic factors are those substances which prevents fatty liver and all, right? So LCAT. So this LCAT binds to the HDL disc. HDL, when it is synthesized, it is synthesized in a discoid shape. Disc shape ladder, oval shape ladder, nascent HDL will be synthesized. So HDL again is synthesized from the liver and liver and intestine and all. And what happens? It is once it is synthesized, or immediately after synthesis, it will be discoid in shape. It is having a disc shape. It's a small molecule. And what happens? When it carries out its function or during its metabolic process, what does it do? HDL collects the cholesterol esters from the peripheral tissues, so that slowly it gets bigger and bigger, right? And the cholesterol from the cell is transferred to the HDL with the help of a protein known as cholesterol efflux regulatory protein, CERP. So it's a protein which takes up the cholesterol from the peripheral tissues into the HDL. So HDL is being transferred with the cholesterol with the help of the enzyme or protein, cholesterol efflux regulatory protein. So it's an ABC protein, that is ATP binding cassette protein. And this ABC protein, it's one of the major regulator of cholesterol hemostasis. So this protein transfers more and more cholesterol from the peripheral tissues into the HDL molecule. And again, this is carried out with the help of the enzyme lecithin cholesterol acyl transferase, LCAT. So cholesterol is converted into cholesterol esters, and it's a C2 of the lecithin contains one molecule of PFA and is transferred to the 3-hydroxyl group of this polyunsaturated fatty acids getting attached onto the 3-hydroxyl group of the cholesterol molecule, so that the cholesterol is made more safer, right? And it is entering, it is taken into the HDL, discoid or nascent HDL molecule. And such an HDL molecule which is now packed with the cholesterol is known as HDL2. HDL3, right? So the nascent HDL is HDL1, and it is discoid in shape. It is discoid in shape, and this discoid or nascent HDL will be now packed with more and more quantities of cholesterol esters, which is derived from the peripheral tissues, right? And this discoid, so that it is getting bigger in size, and this bigger size HDL, when compared to that of the nascent HDL, this HDL disc shape will be converted into spherical shape. So as more and more cholesterol is getting packed into the disc-shaped HDL, it becomes spherical, and such an HDL is known as HDL3. And again, more and more cholesterol esters will be getting attached. Along with it, what happens? TG, phospholipids, etc. All will be released into it, right? And this slowly move towards the liver cells. When the HDL3 remains in the circulation, the cholesterol esters from the HDL, that is HDL, it collects the cholesterol esters from the peripheral tissues and enters into the blood, and from the blood it moves towards the liver. And during its course from the peripheral tissues to the liver like a what happens? HDL delivers what the ApoC, ApoE, അതുപോലെ cholesterol esters, etc. towards the IDL, VLDL, etc. Clear? So that the HDL will be the TG, etc. will be transferred from the HDL molecule towards the VLDL, IDL, LDL, etc. And these HDL particles are called, these HDL particles now will be having, or they are now rich in TG. They are known as the HDL2. And again, they will be becoming more and more spherical, bigger in size. So what happens is that the HDL molecule, nascent HDL molecule is synthesized, right? And this HDL will be collecting the cholesterol esters from the peripheral tissues, right? So once it is synthesized, or immediately after the synthesis, it is discoid in shape. So this disc-shaped small HDL molecule start collecting cholesterol esters from the peripheral tissues, so that it becomes more and more bigger. And during the addition of this cholesterol molecule, cholesterol esters, what happens? It becomes, the disc shape will be converted to spherical shape, right? So this HDL molecule now, which is rich in cholesterol esters, we call it as a HDL3. Now the HDL3 comes out of the peripheral tissues and it will be liberated into the blood, or it is entering into the blood, and it starts moving towards the liver. And during the course of its journey from the peripheral tissues or from the extrahepatic tissues to the liver, what happens? This HDL3 slowly starts liberating the cholesterol esters. This cholesterol release and towards what? VLDL, IDL, LDL, etc. Right? LDL and in return, what happens? It collects the TG from the VLDL, LDL, etc. Right? And now this HDL3 is having more quantities of TG rather than cholesterol. Right? Such an HDL molecule is known as HDL2. And this HDL2 now enters into the, or it reaches the hepatocytes or hepatic liver cells. And in the liver cells, what happens? The hepatic lipase causes the breakdown of the HDL molecule and liberates the TG, the cholesterol esters, etc. With the help of the receptors. HDL2 comes and binds on the receptors on the liver cells and will be endocytosed. And within the hepatocytes, what happens? Lipase enzyme comes, and this lipase enzyme breaks the HDL molecule and releases the contents. And this is how the metabolism of HDL takes place. Right? And the transport of the cholesterol from the peripheral tissues back to the liver with the help of HDL molecule is known as reverse cholesterol transport. Okay. So it is the smallest of the lipoprotein molecules. It is the densest because it is having more quantities of proteins rather than lipoproteins. Lipids, and it is most abundant in the apolipoproteins, mainly ApoE and ApoC. And the main apoprotein that's functioning in the HDL is the ApoA1. Right, and they carries out the reverse cholesterol transport. They carries out the esterification of the cholesterol. That is, cholesterol will be bound with lecithin molecule or polyunsaturated fatty acids. So carries out the esterification of cholesterol with the help of the enzyme lecithin cholesterol acyl transferase, and is a reservoir of apoproteins. Right. So this is how the metabolism happens. The intestinal cells and all HDL will be synthesized. Right. HDL will be giving the ApoE to the chylomicron remnants, and again ApoC, ApoE, so that to the chylomicrons. This chylomicrons will be having ApoB48, right? It is converted into it. Chylomicrons, what does it do? It will be liberating the TGs, right? And becomes chylomicron remnant. And the chylomicrons will be releasing ApoA1 and will be taken up by the HDL molecule, right? And similarly in the liver, what happens? This is a metabolism, total metabolism. Liver synthesizes VLDL with the ApoB100. ApoE and ApoC are derived from the HDL molecules. And VLDL will be reduced in size to give VLDL remnants. Ideal LDL KI marum. Right? This is how the metabolism will be taking place. And they are synthesized in the liver in small intestine. It can be synthesized in small intestine also. With the highest protein content, and when secreted they contains no cholesterol. It goes and collects the cholesterol esters from the peripheral tissue and then come back to the liver with the help of ApoA1, ApoE and ApoC2.